Okay, students, we're at the last lesson, Mod 4, Topic 1, Lesson 4. Do the two at the bottom of the page for warm-ups. When you are done, you can go ahead and hit play. See if you got them right. All right, here we go. A stack of 100 copies of the same book. Okay, that'd be a rectangular prism. Stack of 100 tires, all with the same radius. I'm in a cylinder. Describe a stack of objects that best resembles each geometric symbol, or solid, I mean. A cylinder. Obviously, we have a stack of congruent discs. A triangular prism. Stack of congruent triangles. Okay, remember they gotta be congruent. Okay, that's why it says same book here, same radius here, congruent, meaning congruent. All right, let's go on. Let's go on here. Okay, building the pyramid and cone volume formulas. Remember, volume we know is three-dimensional because we have area of the base times the height. Okay. We are just going to go past this and actually get to problems. So it's not as long. Okay, page 677. Okay. Denny says an oblique pyramid, remember oblique is an angle, so we see it's an angle, it's a pyramid. A pyramid has only, a pyramid comes to one point at the top, for example. Pyramid comes to one point at its apex. Okay, at the top there. So anytime you see just one point there, that's a pyramid, or a cone if it's a circle base. It's a pyramid if it's in a polygonal base. So cone and pyramid are almost the same, except for cone has a circle base, pyramid has any polygon for its base. Oblique at an angle. Okay. Remember the area formula for it for both of these right now is 1/3 area of the base times the height. Whether it's a right pyramid or an oblique pyramid, it's still 1/3 area of the base times the height. Okay, so now you have to find the area of the base. Base right here. Find the area of that base times its height. Remember, height has to be at a 90-degree angle. It has to be perpendicular to the base. So none of these could be the heights. It has to be perpendicular to the base. And there's the height right there. Find the area of that base, and it's 1/3, which means if I did the volume of 3 of these, that would form a rectangular prism. Okay, I mean I can get 2 more of those into that volume right there to make it rectangular. Because remember, rectangular prism is area of the base and the height. This is 1/3. It's only going to cover 1/3 of it. Okay, so here we see that right here. 1/3 area of the base times the height. Volume of a cone, 1/3 area of the base times the height. Again, this is the general formula for cone or pyramid. Remember, they're almost the same, except for a cone has a circle base, pyramid has a polygonal base. Polygon. Okay, right circular cone because it's vertical to its vertex, and right because again it's vertical, and there's its height. Regular means all 4 where regular is equilateral and equiangular. So each of these is the same. So this is four-sided. A four-sided figure has all the same sides. Okay, versus a square. But regular, remember, equilateral and equiangular. Okay, let's go to some problems here. No, okay, do that. Let's get to, here we go. Explain how you know the formula for the volume of a cone is 1/3 area of the base times the height. Okay, so again, if I had a cone like this, I can get another one of these right here, and another one of these. I'll go over to just right there. Okay, so if I drew it accurately, you'd have 3 total cones would make the area of the base times the height, or prism, or cylinder. So 3 cones can fit inside this cylinder. Remember, the area of volume of a cylinder is area of the base times the height. Okay, so it's 1/3. Okay, you get 3 of those in a cylinder. Let's go to the next. It's going slow here. So that's why sometimes it's messing up. Comparing shapes and volumes. That's why you see it moving different places. Okay, surface area now. The lateral surface area of a 3-dimensional figure is the sum of the area of its lateral faces. Notice it calls lateral surface area. No book calls it lateral surface. It's called lateral area. That's why you didn't see me underline that. LA for lateral area. That's what's in all books. Surface area, they call it total surface area. Again, you don't call it that. You just call it surface area, SA. Okay, this is the only book that calls it this. Surface area is the lateral area plus the base or bases. Did I write that down here? No, I did not. Okay, so surface area, SA, equals the lateral area, total lateral area, plus the base. It could be, if it's a cylinder, so that is 2 bases, but it could also be if it's a cone or a pyramid. So this would be cone. This is a prism or cylinder. Prism/cylinder. Surface area of a cone or pyramid, it only has 1 base. So it's going to be the lateral area plus 1 base. So that's, again, these are the general formulas because it's not breaking down specifically. It's the general ones. If it's a prism or a cylinder, it's got 2 bases, so it's lateral area plus the area of the 2 bases. The surface area of a cone or pyramid has only got 1 base, so lateral area plus area of 1 base. Okay. So volume of a cylinder is area of the base times the height. That's a general formula for prism or cylinder. And specifically, it's pi r squared h, which we already did in the last lesson. Lateral means side. Okay, we've talked about that before. And face is any side of the object. That includes the bases. Or base, if there's only one, if it's a cone or pyramid. Okay, vocabulary right there. Okay. Okay. So a cylindrical paint roller has a diameter of 2.5. So the radius is going to be half of that, 1.25. And a length of 10 inches, which is going to be its height. Okay. It's just on the side, right? So you have on the side, here's your roller. So this is its height. And radius from there to there, 1.25. Okay, if you need to draw the picture. Apply the formula to find the lateral surface area, or just lateral area of the paint roller. So the lateral area for cylinders 2 pi r, oops, forgot the pi, 2 pi r h. Okay, because remember, if I make a little slit there and unroll, it's a rectangle. Okay, the length all the way around of that rectangle is 2 pi r. That's the circumference of the circle. And then times that h right there. So in this case, it would be 2 pi r, we already said it was 1.25, times the h, 10. Okay, so 10 times 1.25 is 12.5, times 2 is 25 pi. And whatever the units are, inches, and its area, so it's squared. Remember, area is squared, whether it says lateral area or just regular area. Anytime it says area, it is squared, volume cubed. Total surface area would just be the surface area. So now you would add on, you'd have that 25 pi from the lateral area. And then how many bases does it have? It has 2 bases. Pi r squared, right? So I have 2 times pi r squared. So I have 25 pi plus 2 times pi 1.25 squared. Okay, and then you can put that in the calculator. Okay, and get whatever that answer is. I don't have the calculator up. Let's see here. Graphing calculator. Start. Calculator. Clear. Okay, so go back. 1.25 squared times 2. 1.25 squared times 2. 3.125 pi. 3.125 pi plus the 25 pi. And since they're both in pi, I can put those together to 28.125 pi. And then what is the inches squared? Square inches. So there's the surface area. We added on the 2 bases now. Okay. Okay. Next. Sketch the bases. Here's the bases. And then let's change the color to green. And that's lateral face, lateral face, lateral face, and the back side is lateral. Those are your lateral areas. And then your 2 bases there. Okay. Oops, wrong direction. Okay, so here's an application, a true problem here. He calculates 3 different lateral surface areas. Lateral area 1, 2, and 3. Is David correct? So we calculate the lateral area of each one here. Okay, so let's go ahead and get rid of that. Fill it in here. So here, remember, this is the base, and then the one you don't see back there is a base. Base 2, base 1. Okay, we have lateral area there, lateral, let's change the color. Lateral area there, lateral area, we'll call it 1, 2. It's not the same as this 1 and 2. And then this lateral area here, 3, and the back side, the back lateral 4. Okay. So we have 6 here times 2, because we have 2 of these, the front and the back here. 6 times 2 is 12 square feet. And then here we have 6 times 2 is 12, but we have 2 of those, 24 square feet. Okay. So you could actually, it does depend on what you want to call the base. Most are going to call the base the top and the bottom. Okay, here and here. But when it's a rectangular one, you can actually call any of them the base. I could have called that the base and that base, and then I would get different lateral areas. Okay, so that is possible. Okay. So there's my lateral area, 36. That's why I use the top and the bottom. And then the area of the two bases, 3 times 6 is 18, times 2 is 36 square feet. So the surface area is, that's the area of the two bases, 36, plus the lateral area we just found, 36, for a total of 72 square feet. Okay, which is why I have that right there. Okay. So they made these the bases here. Identify the length, width, and height. Okay, so length, width, height. Okay. All right, a right square pyramid. Right means that this vertex, the apex, is directly above the center. That makes it right. If it was anywhere off to the side, it'd be an oblique square pyramid. It's square because the area of the base, the shape of the base is a square, they're telling you. So they told you here in it, and it's a pyramid, obviously it's got one point. Sketch the base and lateral faces, include the dimensions. Okay, so the lateral area, this is called the slant height. That right there. Now I believe in Edulastic, in Mathia, they call it differently, put a more complicated formula in there, because Ace was asking about this, and I said, boom, just use this formula. This is what all books use. So don't worry about what Mathia is using in there. Just use this formula. That's what every book uses, always has. 1/2 LP. L is called the slant height. That goes from the vertex, the midpoint of the base. Okay, so we're talking about this triangle. We're talking about trying in the area of this triangle. Remember, the height and the base are at 90 degrees. So there's really the height. Okay, that's the slant height of one of the sides of the triangles. All pyramids are made up of triangular lateral faces. And then, of course, this would be the base right here, right? Base and height are at 90 degrees, which is just S, that's side length. So for all the lateral ones, that just be for one. So some people have difficulty memorizing 1/2 LP. Well, what you can do is you can just calculate the area of one of these, as I used to do in high school, and just multiply by how many there are, 4, because there's 4 sides on the base there. So I can just do 1/2 base times the height of one of these sides right here. Of course, that'd be the base, and that would be the height right there. And take that answer and multiply by 4. Well, that's what this is doing when you take the perimeter. It's got 4 S's there. Okay, times the slant height, because the slant height is going to be the same on every one of those. Okay, and that's what I said right here, or the area of one lateral face, I just showed you, the 1/2 base times height, times 4 of them. If you have trouble remembering the 1/2 LP. Okay. Okay. For a cone, it's pi RL for the lateral area. And then the area of the base. So here's your lateral face. Okay. And then this right here is called L, slant height. They're calling it S. Forget the S there. Nobody uses that. This 2.5, this right here, everybody uses pi RL. Okay, so notice they put pi RS. Everybody uses pi RL for slant height. So that's what I said right here. Cross out the S, put an L for slant height. So that's what it is for a cone, pi RL. Okay, so I have that right here. Lateral area equals pi RL. Surface area is that lateral area, which is right there, pi RL, plus the area of the base. There's only one base, which is pi R squared. So here again, this is the general formula. This is the specific one for a cone. You can always apply the general to any of the specific ones and go from the general to the specific. You just have to know the shape of the lateral area and the base. Okay, so this is what I'd be using in Mathia and on your test. Okay, so let's do an example now. lateral area and total surface area, or just surface area, lateral area and surface area of the cone round to the nearest hundredth. So I've written it out here. So lateral area is pi RL. Okay, so pi R, notice they tell me the diameter is 10 feet, so R is 5. Pi R 5, notice I put it right underneath. And L, slant height, they go ahead and tell me is 6.4. Fill that in, round to nearest hundredth, and you get that right there. Now surface area is that answer, which I have right here, plus pi R squared, pi 5 squared, 25 pi. So I put 25 pi in the calculator, plus the 100 point that, add that together, and I get 179.07. You should plug that in to make sure you get that. Okay, so this is what you'll do in your Mathia. Okay, and on the test. Okay, sphere. We have the volume of a sphere, 4/3 pi r cubed. Remember, it's always going to be cubed for volume. And we only have one piece that we're dealing with here, the radius. So if they give you the diameter, I split it in half to get the radius. Okay, so 4/3 pi r cubed. That's it. So if it says find the volume of a sphere whose given radius is this, it says 4/3 pi, I just did that, 4 cubed is 64. Okay. So 4 cubed is 64 times 4 is 256 pi over 3 is the final answer for the exact. And then whatever the units are cubed. Okay. That's just more practice. If you wanted to, it's just straight right here. Surface area. Again, they don't usually call it lateral surface area. There's only a surface area and a volume of a sphere. There's no lateral area of it, or they can call it the same thing. Lateral area or surface area, the same thing of a sphere. And that is 4 pi r squared. Most just say surface area. It's 4 pi r squared. Again, you just got to find the r squared times 4 and pi. And then if it says to round, you round. That is it. Okay, volume and surface area to solve problems. Okay. Okay. I'm just getting worn out here. I'm taking a break. Okay. Describe a strategy for approximating the volume. Okay. It's because this the internet's slow, so it's pausing in between and messing things up. That's why it keeps skipping like that, just so you know. You didn't hear me say it earlier. Volume is pi r squared h. Okay, so I'm looking at this right here. That radius is 2 inches. Oh, that radius right here, sorry, is 4. This radius is 2, and this radius is 3. So if we just take the average of it, the average would be 3, which is why I use 3 right here. Pi r squared, and then h, the height right there, 12. So exact answer would be 108. That's exact. If we're following that in there. Of course, it's an approximation. You know, it's not truly exact. It's not an actual cylinder. So that's probably why I had approximation here, because we just approximated using the 3 there. The surface area would be to include the 2 bases. And again, we use 3 as the average. So 2 pi and then 3 squared. So 18 pi. That plus, oh, that was the volume. Sorry, so we're done with volume. Lateral area is 2 pi RH, so 2 pi 3 times 12. So 36 over 2, 72 pi, that's a 7. 72 pi plus 18 pi is 90 pi square inches. That's our approximation. So if they have something like that on the DCAS, you just take the average of them, okay, and do that, just so you know that. Okay, so last one, we have volume of a sphere. So again, lateral area, or surface area, same thing as 4 pi r squared. R is half of that, that's the diameter. So it'd be half, 27.5, that'd be filling in to there. Okay, volume, again, right there. So this is the height. We're not using that at all. Okay, that's just an extra piece given there. Okay. Now, if it's a gumball machine, we have a circle or a sphere plus that right there, two different shapes. You just add them up, calculate them separately. Okay. Let's see. Remember, this is slant height. This is the actual height. Because the actual height's at 90 degrees. Slant height right there. Okay. Volume, remember, is 1/3 area of the base times the height. So this height is that H right there. So not the L, not the slant height. Area of the base, it must be a square pyramid. Yes, square right there. A side is 230, so it would be 1/3, and then r, side squared, so it'd be 230.4 squared times the height, which is 140. Oops, forgot the 146.7. Okay, that'd be the approximate volume right there. So you have to know which to use, slant height or height. Slant height is only used in lateral area. Actual height is used for volume. So they're going to give you that to see. Okay, I think that is it. We've covered everything we need to right there. Yes. Okay, 27 minutes.